Hey everyone and welcome! Today we're diving deep into a mystery that's happening all around you, literally right this second, the incredible physics of sound.
I mean, really, have you ever stopped to think about it? You say something, and poof, the words just magically travel across the room and into your friend's ear. How on earth does that actually work?
So, let's start with the biggest question of all. What is sound? Is it some kind of invisible force pushing its way through the air? Or is it something else? Could it actually be a form of energy?
Okay, so instead of me just giving you the answer, because that's boring, we're going to do what real scientists do. We're going to find the proof ourselves with a really cool experiment.
First thing you need is a hollow cylinder. An old tin can with both ends cut off is absolutely perfect for this. Then you're going to take a piece of a balloon and stretch it super tight over one of the ends. This little contraption is going to be our sound detector. Now here's where it gets really clever. We're going to stick a teeny tiny piece of a mirror right in the middle of that balloon. Then we take a laser pointer, shine it at the mirror, and aim the reflection so it makes a nice steady dot on a wall. That little dot, that's going to tell us everything.
All right, we're all set up. But before we do anything, I want you to pause and think like a scientist. Make a prediction. What do you think is going to happen to that little red dot on the wall when you shout into the open end of the can? Go on, lock in your guess. You ready for this? When you shout into the can, that little spot of light, it dances. It goes crazy. It zips and wiggles all over the wall, making these awesome patterns. It is absolutely not a steady dot anymore.
So, whoa, why did that happen? Why would just shouting into a can make a laser beam dance around like that? More importantly, what does this awesome result actually prove about what sound is?
That dancing light is the key that unlocks the whole mystery. So let's break down exactly what we just saw and finally reveal sound's true identity. It all boils down to one simple, super important word: vibration. A vibration is just a really fast back and forth movement. Your shout traveled down the can and physically pushed the balloon, making it wiggle or vibrate. That dancing light, that's just a giant magnified version of those tiny vibrations.
And here's the fundamental rule in physics. If something is moving, it has energy. Specifically, it has what we call mechanical energy. So think about it. If your shout made the balloon move, then your voice must have carried energy to it.
And there you have it. If you're ever in an exam and get a question asking you to prove that sound is energy, this is your perfect 4-mark answer. The sounds from the shout, which is energy, made the balloon vibrate. The vibration caused the light to dance, proving there was motion. Therefore, sound is a form of mechanical energy. Boom. Done. And once you know this, you'll see it everywhere. Look closely at a speaker cone when music is playing. You can literally see it moving. Hit a drum, and the skin shakes like crazy. Even your phone vibrating to make a sound is the same exact principle. It always starts with a vibration.
Okay, awesome. We figured out that sound is energy, created by vibrations. But that leads to the next big question. How does that vibration actually travel from, say, my mouth, all the way through the air to your ear?
You know, this question actually puzzled some of the greatest minds in history for centuries. Way back in ancient Greece, Pythagoras had a pretty good guess that it involved a to and fro motion of air. Later, giants like Galileo and Bacon thought so too. But it wasn't until Sir Isaac Newton that we got the first real explanation of how sound propagates, which is just a fancy word for travels.
So here's how it works. Imagine a vibrating guitar string. As it moves forward, it squishes the air particles right in front of it together. That's called a compression. Then, as it moves back, it leaves a space where the particles are pulled apart. That's a rarefaction. Sound is literally a wave of these squishes and stretches, compressions and rarefactions traveling through the air.
Okay, time for another classic physics question. If sound travels by pushing and pulling on air particles, then why are all those epic spaceship explosions you see in the movies completely wrong? Why should they actually be dead silent?
The answer is so important. Sound needs a medium. It needs stuff, particles to travel through, whether it's air, water, or even a solid object. The vacuum of space is, well, it's empty. There are no particles to push and pull, so no medium means no sound. It's as simple as that.
And to bring this all the way back home, get this. That balloon we stretched over the can, it works almost exactly like your eardrum. Those waves of compression and rarefaction travel into your ear canal, hit your eardrum, and make it vibrate.
And then your amazing brain takes over and translates those vibrations into everything you hear. How cool is that?
You guys have done an amazing job. We've covered some huge ideas. So before we finish, let's do a super fast recap to lock in the 3 most important takeaways you absolutely have to know.
Number 1, the big one. Sound is a form of mechanical energy. Remember, it can cause motion, it can do work.
Number 2, all sound, every single sound, starts with something that is vibrating. No vibration, no sound, period.
And finally, number 3, sound can't travel in a vacuum. It absolutely must have a medium, a solid, a liquid, or a gas, to carry its energy from one place to another.
And that's it. If you've really wrapped your head around those 3 key concepts, you have a brilliant foundation for the physics of sound. And trust me, if all that made sense to you, you are already ahead on 90% of students out there. Thanks for joining me for this explainer, and never stop being curious.